So, first of all, can anyone tell me how can I tell that a term is algebraic? What's the thing that makes it? Pardon? Okay. You bet. The only difference between arithmetic and algebra are the introduction of the variables, which are just represented by what kinds of things? Go ahead, anybody. Letters. There you go. Right? So A, B, C, D, X, Y, Z. Does it matter what letter I use? No. And what we do is now in this level is when we're asking specific questions, we try to use variables or letters that make sense. So if we were measuring how many dogs, then we might use D, right? Okay, so we might use descriptive letters. Later, you're going to find that it gets more formulaic, there are more formulas. We've already looked at some that where we were looking at very specific letters for a specific reason. What did capital A stand for? Do you remember? Area. B was base, and H was height. Remember, that's the formula for area of a triangle. Okay? So you were doing algebra, you just didn't know it yet. All right, so what we're going to, let's talk a little bit more. Remember that all algebra is made up, since we have more than just numbers now, algebra is made up of what are called terms. And from our discussion last time, does anybody remember how many parts every term has? 4 parts, exactly. Good deal. And it's important to remember that because if you don't know the parts of a term, then you're not going to know how to put them together or take them apart, which is taking them apart is what we're going to do a lot of. Okay? So, what is the first part of every term? Anybody remember?
Oh, yes.
Go ahead.
The sign.
The sign, excellent. Now, you haven't done much work with positives and negatives, so you're still thinking of those pluses and minuses as being addition or subtraction, and that's the way we'll still talk about them. But then as we move forward, you'll learn that they have other meanings as well than just addition or subtraction. Okay? Good. What's the second part? Anybody? Sure.
Coefficient.
Coefficient, excellent. That's probably a new word for most of you. But coefficient literally means a multiplier. But for us, the coefficient is just the number part. Remember, that's the hashtag symbol is the symbol for number. And these two parts of a term always go together and do one job. What do they do? What do they tell you?
How many?
How many of something you have, exactly. Remember, algebraic notation is just mathematics for that represents the English language. We do this all the time, telling how many. But in math, you can have plus or minus some things. Okay? Third part, anybody?
The variable.
The variable, and we call that the base, right? The variable. Or variables. Can there be more than one letter in a term? Yeah, we could have A, B, D, whatever. Okay? And on every base or variable, whether you see it or not, there is an exponent. Excellent. Yeah. Okay. So what am I doing here? Just reading your notes, aren't I? So if you have your notes from last time, then all of these answers are there. So that's what I want to try to get you to do, is to get you to see those notes as much as possible. Because if you can remember the process, then you can do the math, right? Because remember we said there are only really 4 operations on all of mathematics. You can add, you can subtract, you can multiply, or you can divide, right? Okay? And everything else is built around those processes. So if we know how those processes work, then we can arrange them and rearrange them in lots of different ways. Okay, one last thing about a term. What are the base and exponent? They're always taken together, and what's their job? Sure. They name the term. Excellent. They're telling you what kind of term you have. You can have an A term. You can have a B term. You can have an XY term. That means it has an X and a Y in it. Okay? Right? So, for example, if we have negative 7b to the second power, the sign is what? Plus or minus? Go ahead, just call out. Anybody? Yeah, all of you. Yeah, good job. The coefficient is what? 7. So that tells us I have minus 7 of these objects, whatever they are, right? A little odd to have minus 7 of something, but you get the gist. The base or variable is the b, and the exponent is the square or the 2 on there, right? Exponent of 2. And those are the 4 pieces. And if you understand the 4 pieces, then you know how terms are put together, and then you can work with them, right? It's just like learning the alphabet. You had to learn the alphabet before you could learn how to spell, right? Then after you do it, then you can spell simple words, and now you're able to do much more complex words, even words you've never heard before. Okay, good job. Any questions about the parts of a term or what they're called? Okay, excellent. So the next thing we want to do then is what we want to do today is we're going to talk about, I want one more thing. I'm sorry. We talked about this briefly, but I didn't write down the actual name for them. We talked about having number terms. Remember, number terms are not algebraic because they don't have what in them? Variables, exactly. But they are still terms. And what they're called constants. Now, they're called constants because their value can never change. If you have a 7, that means there are how many of them? 7, right? It never changes. Now, if you have an x, don't know how many that is? And depending on the sentence it's used in, it could be any number, right? Then that's why they're variables. So we have variable terms and we have constant terms. And constants is just another way of saying a number. 2 is a constant, right? Because its value never changes. We know exactly what we're talking about. But b, is that a constant? No. Okay? Good. Because today what we're going to do is we're going to be talking about something called like terms. Again, this is an idea that is not new to you. You do this all the time. You've just probably never put it together in mathematical form. Like terms are objects that have the same name. So this time I'm going a little bit backwards because the name of the term is really 2 parts of the term, right? Which 2 parts?
The variable and the exponent.
Exactly, right? They have the same name. So that means they have the same base or variable and the same exponent. If there is an exponent. There aren't that often. There aren't always, but there can be. So, just like I would say, okay, so we have these 2 desks up front, right? Okay, there's one desk and then there's another desk, right? We wouldn't say one desk and then another desk. We would say what? 2 desks, right? Okay, but what about a desk and a chair? Can I say one desk and one chair makes 2? No, because they're not the same. They're not the same objects, right? So I can't combine them together. I can't put them together. They're not like terms. And that's the same with the number terms. If they have the same name, then they are considered to be like terms. And why that's important is I wouldn't walk into the room and say, "Oh, look, there's one student. 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 Would you? No. That would be ridiculous. You would go, there's 16 students in the room, right? In other words, you would collect or combine them all together because it just doesn't make sense to say 1 and 1 and 1 and 1 and 1 and 1 and you'd be here forever, right? So we're used to doing that. If you go out and ask you how many cars in the parking lot, you're not going to go, "Oh, well, I saw one car, then I saw one car, then I saw one car, then I saw one," right? You'd say, "I went out there and there were 12 cars in the parking lot." Yeah? In other words, you would give me a total, a combined total. So we're going to talk about combining, or it's also known as collecting like terms. Combining or collecting. If you think of combining or collecting, what operations do you think that is? Adding? Or you could, this thing, I swear. Adding, or what else? What other operation is like addition? Well, think about the opposite of add is what? Subtract. We could take objects away from each other too, right? I could come over there and take away one of those desks, right? So collecting or combining is either adding or subtracting. So we're talking here about either adding or subtracting. Sorry about that. Let me know if that goes blank again, because sometimes it times out. All right. So first thing I want us to do is I'm going to put some terms up on the board, and I want you to just tell me, are they like? And the other phrase for that is unlike. Unlike means they're not like terms, right? Okay. So what if I have? Oh, of course, yes. Okay, no worries. I didn't know how long it had been blank. We're going to decide if things are like or unlike. Like meaning they have the same name. Unlike meaning that they have something different, right? Now, how about if I have 5 x's and 6 x's? Are those like terms? What kind of term is this? An x term, right? So an x term, right? Does it matter that this one's a 5 and that one's a 6? No. They don't have to be identical. What kind of term is this? It's also an x term. Okay? So they're both x terms. Remember that the part that makes them alike is their name, the base and the variable, right? Not how many. Okay? If I have 2 desks, can I add 7 more desks to the 2 desks? Yes. But if I have 2 chairs, can I add 2 chairs to 3 more desks? No. As long as they have the same name, then they're considered to be like terms. Excellent. What if I have 3 and 9? Are those like terms? Be careful. That's just simple arithmetic, isn't it? Yeah. They're just constants. They're both just number terms. So they are alike, aren't they? They're constant terms. Okay? 5y and 3x. Like or unlike? Unlike. What kind of term is this first one? A y term. What type is this one? An x term. Are y's and x's like terms? No. Okay? Now, what if I had 3ab and 6ba? Be careful with this one. They are like terms. One of them there's something wrong with. Which one is there something wrong with?
6b.
This one's wrong. Why is it written wrong? The letters, if you have more than one letter, they should be in alphabetical order. And this is exactly the reason why. Because it's easy to see that an AB is the same as an AB, but it's harder to see that an AB is the same as a BA. And that's why we always make sure to put them in alphabetical order. Okay? All right? So it's just a matter of looking at and asking yourself, what kind of term is it? Okay? You wouldn't go in and I couldn't say, go count those. Right? Go count what? But if I said, go count the chairs, you'd know exactly what I'm talking about. And that would be so normal. If I said, go count those, your first question would be, go count what? Right? But in algebra, I can tell you to collect the like terms, and you're like, okay, I'll just collect everything. Right? So you've got to remember the same questions that you need to ask of life, you need to ask about algebra, right? It's just a language. Okay. Now, so what we can do is any of these terms that are like terms, we can combine or collect by simply changing the number of that you have of them, right? So let's say that we have, let's just go ahead and just a couple more. Say we have 5x's plus 3x's. Now the first thing we need to ask, we know that they're algebraic terms, right? First thing we need to ask, are they what kind of terms? Like terms. What kind of term is the first one? X term. What kind of term is the second one? X term. So are they like terms? Yes. If they're like terms, okay, We need it. Whoops, sorry. Let me get the steps then. To combine like terms. Sorry, I'm not ignoring you back there. Okay. To combine like terms. First, of course, they have to be like terms, but we've already determined that. All we're going to do is keep the base and the exponent. Tables don't suddenly become chairs, right? When you have more of them. So remember, the base, keep the base and exponent. And then you're going to combine the coefficients. And the way that you combine them is determined by if you're adding or subtracting the pluses and the minuses, right? So just combine them. And we say combine because that means either add or subtract. Instead of saying add or subtract, we can just say combine. Okay? So, first of all, what type of term is the first one? X term. What type is the second one? So are they like terms? Yep. So that means we're going to get more x. So they are like terms. So when we finish, we're going to get x terms. Okay? How many in the first one? 5. Plus how many in the second one?
3.
And 5 plus 3 is just plain old? 8. So my completed answer is just 8 x's. I'm sorry, yes, I was putting you on.
When you're writing an x term, don't you have to go like that so it's cursed so you don't mistake it as a time?
Yes, but, and you weren't here for that, but exactly. When you're writing your x's, if you're going to use the x for multiplication, remember that they use a very straight x for that, but then when they use it as a variable, they do that little, they make it look funny, right? But what was my advice for you? Sure.
Use a dot for multiplication.
Yeah, instead of saying 3 times 5, we can just replace it with a dot, and that way we won't get confused with any of them. Right? Because at some point you don't want to have to be able to tell, oh, is that the x for multiply, or is that the x for the variable, right? So we're just going to replace it. And that's a perfect, wonderful question, right? Because we had just talked about it another day when you weren't here, and so, but that's great, and it's a wonderful reminder. Okay? So what are you going to do with the base and the exponent? Keep them, right? X's and x's just make more x's, right? Okay? But what are you going to do to the coefficients? Combine them, which means either add or what? Subtract. Combine means add or subtract. Excellent. So what if I have 12y's plus 4 minus 3y's plus 8 minus 2x's? This time I have a lot of terms, right? Can anybody tell me how many terms I have?
3.
Well, there's 3 different types of terms. I agree with you there. And there will be 3 terms in my answer. But if you look at it, I have... Oops. Remember, let me just erase that. So remember that every time you see a plus or a minus, then you know it's the beginning of a new term. So here I have 12y's. That's one term, right? Then I have plus 4. That's another term. Then I have minus 3y's. That's a third term. Then plus 8y. I'm sorry, just plus 8. That's a fourth term. And then finally, minus 2x is the last term. So how many terms is that actually then? 5, right? But you're exactly right. There are 3 different kinds up there, aren't there? Okay, let's look at those. What kind of term is the first one? A y term, right? How about the second one? A number, which is called a constant. A constant, right? Then here's another y term, right? Then another what? Constant. And then a what? An x term, okay? So we have y terms, we have constants, and we have x terms in this one problem, don't we? So we do have 3 different types of things. And so that also tells me that when I combine all the stuff that's alike, how many terms am I going to end up with? 3, because there are 3 different kinds. In the end, we can't put them all together. We're just going to have 3 terms in our answer. So the first one is a y term. Here's another y term. So they're going to still be y terms, right? So if I have 12y's minus 3y's, how many y's is that going to make? 9y's, right? Just take 12 minus the 3. The only part that changes is the numbers. If you have 4 apples and I ate 3 of them, right? You only got 1 apple left, but it's still an apple, isn't it? Only the number of apples you had changed. The fact that they're apples stays the same. Then I have a 4 and an 8, which are constant terms, which are like terms. What is 4 plus 8 going to make? Anybody, just go ahead and sing out. That's fine. 12. And notice that they have the plus in front of them. So when I bring it down, I need to keep that plus between them. Because otherwise, they won't be... If I don't separate them with the plus, that doesn't mean combine. That means what operation? When you just stack them together like that. Multiplication, right? The multiplication is the only one that doesn't require any symbol at all if you just got things stacked. And that's not what we're trying to say here. So make sure that if it's plus or minus, you bring down that plus or minus. And then finally, so we're done with all of those terms. The last term is just negative 2x. Do I have any more x's? Or minus 2x, I'm sorry. No. So it's just going to come down completely unchanged. Okay? Now, you could rearrange this if you want. Why would I might rearrange this? I could put them in what kind of order? Alphabetical order. But you don't have to at this point, but we're just going to just for fun right now. I couldn't because I know that rearranging math terms is so much fun, right? Okay, so that means the x would come first, so minus 2x. Now I know it's a little strange for y'all to have the negative in the front, that minus in the front, but it's okay. The minus stays with the 2, right? Then we would have our y term, and since it doesn't have a symbol in front, we assume a plus. So plus 9y, and then any number term or constant always comes at the end. Now, I'm perfectly happy with this answer, but then later we're going to be doing that, but just not now. Mm-hmm.
Is there any way to solve this equation?
No, because it's not actually an equation. This is something called an expression. Can someone tell me why it's an expression and not an equation? Go ahead, anybody. There's no equal symbol, exactly. Now, if it said equal 5 or something like that, then we're set to solve it, right? But because there is no equal symbol, it's not an equation, it's just an expression. And expressions can be simplified, but they can't be solved. Good question, excellent question. All right, now, okay, so let's see. What if I have, I don't know, 3ab plus 4y's plus 3y's plus 5ab plus 2. I keep writing pretty much the same problem, sorry. It's hard to get a bunch of different ones. Okay, so first of all, it's not an equation, is it? It's an expression, and I can tell that because there is no what? No equal symbol. So I can't solve it, but I can simplify it. And to simplify it, that means I need to do what to them? Come on, you. Combine. What are they called? Like terms. There you go. Combine like terms. Okay? Now, so combine like terms. If I'm going to combine them, and I have to first know their like terms by looking at what they are. So if I look at the first one, what kind of term is this first one? An AB term, right? It's not an A or a B, it's both of them, an AB. Do I have any more terms up there that have AB in them? Yes. Sure, there's one right there. So those two, therefore, can be combined. So I have 3 of them plus 5 of them makes what? 8 what? AB. Now they're done, so I'm just going to mark them off. Notice how I keep going down a line on these. It's really good if you'll get in the habit of working down because it keeps things more organized than if you work across. The book likes to work across a lot of times, but it's a lot easier for when you're working them to go down because then the stuff that you've used, you can simply get rid of, mark off, right? Okay. Don't scratch it off so hard that you can't see it because if you make a mistake, you're not going to be able to go back and fix it, right? But you can put a line through it if you want. What kind of term is the next one? A y term. Are there any more y terms?
Yes.
Yep. There's another y term there. So what's 4 of them plus 3 of them going to make? 7 y's, right? But I have to have a symbol in between. So what am I going to use? Plus. There you go. And then finally, the last thing is not a variable term at all, right? It's a constant. Are there any more constants? No. So what am I going to do with that plus 2? Just bring it down and put it at the end. And there you go. How does it look? Pretty good? Pretty clear, I hope. Have y'all seen this before? Combining like terms? So you've had some practice with it before? Okay, because the first class didn't sound like they'd seen it before. So good. All right, so what I'm going to do is, because this comes from a book that we don't have copies of over there. So what I'm going to do is I'm just going to write some on the board. And then I want y'all to practice this while I'm here to answer questions. You can work together. That's fine. Ask your neighbor questions if you want to. I'd prefer you give it a shot by yourself first. Try to work the problem by yourself. But if you get stuck, then ask a neighbor. And then after you've done it, ask your neighbor, is that what you got? Okay? So I'm just going to write one down. We're all going to take a minute to work on it. Right? And then I'm going to call on somebody and get an answer. I'll let y'all volunteer. I'm not going to say, you, what's your answer? So, all right? I won't do that to you yet. Yet. I'm not going to be that mean. It's what I do in my university classes, though. I have a list of all of their names, and I just push a button, and it shows me a name, and I say, Marcy, what'd you get? And they have to answer.
Can we do that?
You want to do that at some point? No. It makes some people too nervous. But how about this? We can do it for notes. You know, in the beginning, in the morning, and the first thing I do when I'm talking to you, I ask you about your notes, where all you have to do is just read it off the page. I can do it there if you don't want. Kind of get you used to it. I'll never ask you to do something out loud or in front of the class that you're not comfortable with. Okay? Yes?
Can I have this in the bathroom?
Of course you may. Go ahead. All right. So here we go. Now, might try to trick you here, you know. You never know with me. So pay close attention. We're going to start off pretty small and pretty easy, but you never know what I'm going to put up there. So here we go. Oh, here's something I didn't really talk about. That's an algebraic term, right? I'm sorry. Yes. Of course. Here's something I didn't talk about. That's an algebraic term. What kind of term is it? It's a y term, right? Okay. How many y's do you see there?
1.
Right. And if there's just one, they don't really write the 1. But it's the same as writing 1y. Like one table. You don't say, oh, look, there's one table. You just say there's a table, right? So if there's only one of them without a number, then you assume that number to be a 1. Okay? You can write the 1 or not. When you're doing the math, it's usually easier to write the 1. But when your answer, you don't have to. I won't count it wrong if you do, but you don't have to. Okay? All right, then. Let's see. Here's your first one. Go. Remember the questions. Are they like terms? And if they are, then combine them. Okay, this one shouldn't take long. Somebody got an answer for me then?
Yep.
Okay. We haven't picked up. Okay.
10.
10 what?
S.
10n, exactly. So these things are like terms. They're both n terms. And there are 11 of them here. And how many here? 1. So 11 minus 1 gives us 10. So our completed answer is 10n. Is all good? Excellent. All right. Well, that one's too easy then. So let's mess with you a little. I got nowhere to be. Say we have Well,
the letter x and then the letter y.
just both of them. They're just variables. It literally means multiply, but can you really multiply them? Because you don't know what they are, so it doesn't really matter. Yeah, they're connected with multiplication, but they're both just variables, so it's just the name of the term there. Okay? So yes, it does literally, you're absolutely correct. That means x times y. But since I don't know what x is, I can't do the multiplication, so x times y is just xy.
What I mean is the x
Multiplication
Is that
as in
times
3
y
times
or
y
xy?
or xy. Is it
Is that
3
like
times
that?
They're identical. They mean exactly the same thing.
There's 3x and y, so the x is a variable.
Okay, so it's
Three.
not
So the
3
x is a-
times y.
I see what you're saying is the x multiplication.
Yeah.
No, I'll never use it as multiplication.
Okay.
Okay, I get it. I'm sorry. It takes me a while. But see, I would never use x as the multiplication symbol, and that's what y'all are used to using, so that's why I'm confused. And besides that, I stay confused.
With the 4y and x, would you do the x as a plus x?
No, because there's not really a plain old x up there, is there?
Yes, there is on the end. I get what this means.
Is there? Okay. Who wants to solve this one? Hey, all right, let's just solve it in pieces. First of all, who can tell me what kind of term is the first term?
Y. XY.
It's an x and a y term, right? Okay, so it's xy, right? Okay. But is this an xy as well? Yes. Is this one an xy too? Yes. But what's wrong with it now is that it's what? Not in alphabetical order. So this should be 3xy's plus 4xy's. Remember that if you have more than one letter, always make sure to check to see if they're in alphabetical order. Now are they like terms? Yes, they're both xy terms. So if I have 3 of them plus 4 more of them, how many does that give me? 7y. xy. Yes, who was that? Question?
I thought
Oh,
it was
okay.
1y and 1x.
Yeah, no, it's anytime you have them shoved together like that, that means they're both the base. You can have more than one letter in the base. Okay? Good deal. So, excellent. So make sure you're careful about watching those. Let's do one with an exponent in it. Now, don't let the exponent mess with you. Just remember that if you do have an exponent, it's part of the name, right? So if I have 2x to the second power plus 7 plus x to the second power minus 3. Let's see if you can combine the like terms for this one.
Can I quickly hand something out to the class?
Sorry?
Can I quickly hand something out to the class?
Sure, just do it quietly. Sure, you bet. Okay.
Everyone, I'm just handing out these little flyers. If you could hand them out to somebody who you know, probably not someone in this class, obviously, because they'll have some too, but just give them to somebody who is aged 10 to 14 and is a girl.
Maybe someone around your neighborhood or
Just Karen, if you
something.
want, I can give it to my sisters neighbor too.
Sure, I'll give you some more then.
I'm giving 5 to everyone. She is 10.
Okay. All right. So we're going to combine the like terms. So who can tell me? Okay, guys, we're not doing that if it's going to cause trouble here. All right. So what kind of term is the first term? Anyone? X to the power of 2, or x to the second term, right? Do I have any more x to the seconds up here?
Yes.
Yes. There's another one right there, right? Now, you know what I should have done? Here, I'm going to change this one a little bit. All right. It's better. Now, this one is a like term to this one because they're both x to the second power. Do I have any more x to the second power there? No. But I have some x's. Can I combine x's and x to the second power? No, because remember, if you have an exponent, and the exponent is different, then they're not like terms. And it's easy to see why if you think about what that exponent means. 2 is just the number 2, right? But what does 2 to the second power make? So if you put an exponent on it, you've changed the value, haven't you? So you can't say that x's and x squareds are like terms. Yes?
The x's weren't there before.
No, I just stuck them in because I realized that there was something I wanted to show y'all. So what's 2x squareds plus, how many x squareds do I have here? One of them. So what's 2 of them plus 1 of them going to make? Anybody? Just go ahead and sing out. 3x squareds, or to x to the second power, however you'd like to say it. Good. Now I have positive 7x's, and here are negative 3x's. So what are 7x's minus 3x's going to make?
5x's.
Be careful.
Sorry, 4x.
4x's, right. And since the 7 had the plus in front of it, that makes it bigger. So what goes between them?
Plus.
A plus. Now can I combine those two?
No.
But they're both x's.
No.
No, they're not. This one's an x. What's this one? X squared, or x to the second. So they're not like terms. Yes?
Could you make the 4x into a 2x to the power 2?
No. Because the thing that the exponent is actually touching is just the x. It's not all, and there's no exponent on the 2. If there was an exponent on the 2, it would be right up against it. And we're going to do a section about indexes too, so we can learn those rules and make sure that we know how those work. Okay? Good deal. All right. So we only have about 4 more minutes. So what I want you to do is make sure that your notes are clean and good and well written out, and you have them put away somewhere where you can use them. Because every day, what we're going to do is we're going to come into class, and I'm going to go over those notes with you. You, by the way, because notice I didn't give you any homework. I'm going to give you a maths mate, though. You, however, should be studying your notes so that you can memorize them. So, because it doesn't do you any good to just write down something that you don't memorize later, because you need to be able to remember it when you need to use it, right? Okay?
No, because that's really